Welcome again to Physixify. You are with me, Udit Gupta, and we are continuing from where we left off. We left off at equilibrium. We were doing some problems that we are continuing today. We have the second problem set coming in for you. I hope before we go forward, there will be something that we can revise and then probably go a little ahead. So, first thing I have brought to you is the graph of equilibrium once again. I hope you remember that if we take a u versus x curve, something like this, I hope you can recall that there were three positions, first, second and the third one. So let's place a ball everywhere. And if I ask you which equilibrium is what, I hope you already know that. But let's just mark it out. If I say this is the point A, this is where I'll say I get a stable equilibrium. If I take the point B, I will say this is where unstable equilibrium occurs. And if I take this point C, I will say this is a point of neutral equilibrium. What are the conditions? The conditions are d2u by dx2 should be greater than 0 if I talk about a stable equilibrium. If I talk about d2u by dx2 being less than 0, this is the point of unstable equilibrium. And if I talk about d2u by dx2 equal to 0, I say this is neutral equilibrium. Right. I hope everybody recalls this much. It's not much, but now we have a certain question that we would like to answer. An easy one, I would say. Question number 4, again, continuing from the previous class. What we have over here is we are asked that we mark all the points. Which points? All the points A, B, C, D, E and F with the types of equilibrium. What type of equilibrium occurs at all these points? Now where are these points? So let me draw out the curve for you and the points for you. A, B, C, D, E, F. I hope everybody is able to see all these points, these 6 points that we have. Now what can we say? We can say this appears to be the case of unstable equilibrium, right? First one is unstable. This appears to be stable. This again appears to be unstable, right? This occurs, it seems like it might be stable, but I think it's a neutral equilibrium because there's a flat line sort of a thing over here. So I'm saying D as neutral equilibrium. E again becomes unstable while F becomes stable yet again. I hope this is as easy as it comes. You can probably answer these questions very, very easily, right? So I just wanted to get an idea that, okay, do you remember all these three different types of equilibrium? So now one thing that I can say a little extra in this case is that if I draw these two lines that just appeared for us, a horizontal line at B and a horizontal line at E, what is the inference that I can make? What is the conclusion that I can draw over here? I will say B is a little on top as compared to E. B point is at a more higher level as compared to E. This means I can say one more thing over here which is not mentioned in the question, but it might be asked, that B has a greater potential energy as compared to E, right? Because it is at a higher level, U is more, and E, the point E has a U that is a little less than B. Okay. Alright. Now let us talk about question 5, one of the best questions that you will come across. And what is given over here? You'll see and you can just mesmerize its beauty. That U is given as a function in both X and Y. If you see, 12x minus x cube is the X part of it. Y cube minus 3y is the Y part of it. And then you are asked the same question again, that find the position and type. But I hope that you understand this is a little complicated. Why? Because X individually was given in the previous lessons that we were doing. Now Y is also given. So how will you go about in this question? So whenever you get anything as a function of more than one variable, U here is a function of X and Y. We have talked about this, that we can use partial derivatives. So what I'll do is I'll say that for position, let us say we know fx would be equal to 0. Corresponding to this, I can say minus del u by del x equal to 0. Now please watch, this minus del u by del x is important. You cannot write d over here. Du by dx is not allowed, because when talking with respect to x, since there is a y also attached, you have to use partial derivative. That is the learning over here, and you'll see how this becomes an even more complicated question very quickly. Because if you do minus del u by del x equal to 0, you are going to get minus of, only this part I need to see, 12x minus x cube. If I would like to mark, let us say I mark it in red, 12x minus x cube, you differentiate it, you'll get 12 minus 3x square. And once you solve this up, you will get x2 values, that is plus 2 and minus 2. It is again similar to what we did in, I think, question number 2. Right? You can take the reference from the previous session. But if now I also want it for y, I will say that if fy equal to 0, in that case minus del u by del y equal to 0. And in that case, I'll have to take this differentiation of this term with respect to y. And I hope everybody can say that is 3y square minus 3. Right? We put that equal to 0, we are going to get another thing. Right? We will get y as plus 1 or minus 1. Now what does this tell me? Because I've gotten so much data, I should be able to understand that what it says. It says that if I want to take this position only, this will be my equilibrium position. I want to take this will be equilibrium position. I want to take this equilibrium. Are there 4 equilibrium positions? Yes, there are. But you will not say just x equal to 2 or x equal to minus 2, y equal to 1 or y equal to minus 1. Because now the things are in both x and y. So what I will say is that I can take 2, 1 as one of the positions, 2 minus 1 as the second position, minus 2, 1 as the third position, and minus 2 minus 1 as the fourth position. So first part of the question is done when you say the positions of equilibrium could be these 4. Now I hope you understand that if you have 4 positions, you'll have to do that type thing 4 times to get to the correct answer. No, not 4. You'll have to do it 8 times. Why? Let's try to see what can we do with respect to type. We have done position already. If we talk about the type of equilibrium, what I will say is that you need to calculate del 2u by del x2 and del 2u by del y2 with respect to both x and y. But where all will you find? At those 4 points which we just got. So I will say that let us take the first point at 2, 1. X is 2, y is 1. At this case, I get del 2u by del x2 as minus 6x. I put x equal to 2, I get this minus 12. Next inference I make is that del 2u by del x2 is less than 0, it is negative. And in this case, I can say u is maximum and I have gotten an unstable equilibrium. Now please remember, this unstable is with respect to x. This unstable equilibrium is with respect to x. Similarly, if at the same position at 2, 1, I can also do del 2u by del y2. So if I do that, I get 6y. I put the value of y as 1. I get del 2u by del y2 to be 6. And once I get that 6, I get that this is a positive value. This is greater than 0. And in this case, I'll say u is minimum, or I can say this is a stable equilibrium. But once again, I'll need to remember that this has been done with respect to y. Okay, so with respect to x, with respect to y, you're getting different equilibriums, and this is one awesome place. We call this point, since we have gotten one unstable and one stable, this point is called as saddle point in physics terms. That this is a saddle point, that you have unstable equilibrium with respect to one of the axis, and you have another type of equilibrium with respect to another position. I mean, the position remains same, but with respect to one axis, with respect to x. If you would have been ever to go to do a horse riding, you would see saddle is the place where somebody sits. So on saddle you have one equilibrium which is stable, while if you talk about this type of an equilibrium, it is not stable. So you can search more about saddle point. You can get to know that it is a point where types of equilibrium could be different with respect to different axes. Now one more thing, that final thing that I would like to say over here is that this was only with respect to one point, that is 2, 1. there are 3 more points, and I would like you to cover up all those points. Let me know whatever you feel, whatever you get as your answer in the comments, which point gives which type of equilibrium with respect to which variable, and I will make sure that you get to know exactly what should be the answer. Once again, thanks a lot for watching this session. I hope the doubts in equilibrium would be a done deal for now. And if you do face any problems, do not hesitate, do not forget. Do comment as soon as possible. I am waiting to make sure that I get to your comments and make sure that your learning does not take a pause anywhere. If you loved this class and don't want to miss anything from me, you can subscribe by pressing onto the subscribe button. I hope you already know that. And if you loved this class, you can like it and share it amongst your friends as well. This is me signing off for now, but I'll assure you that the next thing that comes is a brand new lesson in vectors. Do subscribe and you'll get to know very soon. Thank you.